Okay, in this video we're going to talk about another interesting way you can combine functions called hybrid functions, right? So a hybrid function is a combination of two or more functions. I'll write that down. So it's a combination of two or more functions, right? And these will usually be simple functions that you're familiar with. And what's special about them is that each function, right, each of these individual functions that you're combining is it's assigned a different part of the domain. Okay, let's have a look at an example. Okay, so each function is assigned a different part of the domain. Okay, we'll look at this example here, right? Let's see. So we'll do a simple one to start off with. Let's say we'll call it h of x for hybrid, but you can call it whatever you want. So the notation for when you're making a hybrid function is this massive curly brace like you have here. And then within this curly brace, you write all the functions that you're combining, as well as the domain that you're assigning to them. For example, here we could have, so we'll do, okay, let's do negative x. Okay, that's the first function, and the domain that we're giving it is x is less than or equal to 0. Okay, the second function we'll combine is x squared, and the domain we're giving that is x is greater than 0. Okay, just something to note. Actually, I'll tell you that after I sketch this function. Okay, there's our function. So let's sketch our axes. We've got y-axis and our x-axis there. Okay. So how we sketch this is it's pretty easy. If you know how to sketch the two individual components, you can sketch the hybrid function. So the first function, negative x, usually would look like just a straight line with a negative gradient through the origin. That's not quite accurate there. It should be through the origin. That's how it would look normally. But because we've restricted the domain on that one, this is only, h of x is only equal to negative x when x is less than or equal to 0. We can't include all this part that's after 0, right? We have to stop at x equals 0 and include everything that's less than 0, or all the x values that are less than 0, right? So we go up till here, right? Because this is the point where x is equal to 0. That's the first part of our function. The second part of our function I'll do in a different color. So we've got x squared where x is greater than 0, right? And we know what that will look like. That will look like that, right? Just like a quadratic. So that's a hybrid function there. That's easy. So I've drawn this in two different colors. Normally you would use the same color because it's still considered the same function, right? We're sketching h of x. We're not sketching these, h of x is a combination of these two functions. So this is all considered the same function, right? Let's do another example, and I've already got one in mind to make things a little trickier. And in this particular example, yeah, so like I said, we can call it anything we want. I'll call it poo of x, and that's equal to, this time we'll do three functions. So let's do e to the power x all the way up until 0. We will do sine of x between 0 and 2 pi. And we'll do square root of x from 2 pi onwards. Okay, oops, not 0, 2 pi. Okay, how will that look? Let's see. There we go. So e to the x, we know how that looks like. We have to draw it from negative infinity to 0, including 0. So we know that at x equals 0, the value of e to the x is 1. So we're going to have a point 0, 1 there. And then there's going to be an asymptote there, slowly going up to there. Okay. Whenever you're drawing a graph that has an asymptote, you always have to explicitly show the asymptote. and also give the equation. It's a bit hard for me because I don't have a ruler. Okay, even if the asymptote's just, you know, straight along the x or y axes, you still have to draw them. And in this case, the equation of this asymptote is y equals 0. Okay. The next part of the function is sine of x. Okay, that's interesting because sine of x does not start there, does it? Sine of x starts at 0. Okay, we're not including 0, so we're going to have an open circle there. We should label that point as well. That's 0, 0. Okay. We know how sine x looks. It has a period of 2 pi. We're going up till 2 pi, and we're not including 2 pi. So we'll go there, and that's where the other x-intercept will be. So it's going to look like... Oh, sorry. That should not be an open circle because we are including that point. Oh, another thing is, because the amplitude of this is 1, and we've got 1 here, this should also go up to the same level. So I need to modify that a little bit. You do have to pay attention to detail sometimes. Right. There we go. That's close enough. Do one more attempt. Okay, there we go. Okay, so we need to label all the x-intercepts as well. This is pi, comma 0, and this is 2 pi, comma 0. That looks like a closed circle. It's really important to make it an open circle because otherwise you would lose a mark in an exam situation because we aren't including that point, right? That clearly states it's less than 2 pi, not equal to 2 pi. So, whoops. Oh, I will cut that off. Don't want you looking at my personal files. That's okay. Okay, we got the open circle there. Next thing to do is the next part, which is square root of x. Okay, x is greater than 2 pi. So we know that the square root of x looks something like that, if you can just follow what I'm tracing, right? We're only starting from 2 pi though. So we're going to go up to there, you know, and start from there, and I've got a closed circle because we're including that point because it's greater than or equal to. And the coordinates of this point, well, the x coordinate is 2 pi. The y coordinate is just subbing in 2 pi into here, which is the square root of 2 pi. There you go. So, as you can see, well, I find hybrid functions really interesting because you can make some really cool things out of them. For example, you can make the McDonald's logo out of a hybrid function, right? We won't do that in this video, but it's basically two quadratics, right? Sort of joined together at this point here, right? You could approximate that using a quartic. That would be what a quartic would look like, but a quartic would have this little curve here, whereas the McDonald's logo has a sharp point there, right? So it won't be exactly the same. So hybrid functions are really cool creatures. One thing I want to mention is that if I accidentally filled in this point here and it was a closed circle, this would not be a function anymore. It would be a relation, but not a function, because if it's for something to be classified as a function, it can only have one y value for every x value. This is not a function because at this particular x value, so at x equals 2 pi, it has two y values, right? It has a y value of 0 and a y value of root 2 pi, okay? That's why we need to make sure we include that closed circle, because only then it's a function, because now if you draw a line through here, it only has one y value at x equals 2 pi because this is not included, right? So that's an important thing to note.